Water is essential to every living thing. All animals need a continuous supply of water in order to live. In food making and in other life processes, plant water derived from rain. Roughly 1/3 of all rainfall runs off into streams, rivers, and lakes, and these constitute our chief surface water supplies. About 1/3 soaks into the ground and becomes our underground water. Part of the rain is used up by dense forests, which require about 20 inches annually, while grasslands prevail where the rainfall is between 10 and 30 inches. A desert is a sign of meager rainfall. Life here is greatly restricted. Rainfall is unequally distributed, with the result that we find native forests in the west and east, grass in the central states, and sparse desert plants in the southwest. To exist, man requires a continuous supply of water. Springs furnish an accessible, though limited, source. Underground water may also be tapped by wells, such as this old dug well and sweep. Many large cities, some located here by dots, depend upon underground water tapped by modern wells. For other cities, surface water taken from rivers constitutes the only adequate and available source. Some cities take their water from nearby lakes. Surface waters are also made available to certain cities by impounding the headwaters of rivers by dams. America's largest city depends mainly on watersheds for its water supply. New York City needs 1 billion gallons of water daily, an amount about equal to the flow in this river. Wells and cisterns originally used became inadequate, and about a century ago the city started to develop the Croton watershed 50 miles away. The water was carried by an aqueduct here crossing the Harlem River. The continued growth of the city soon necessitated additional water supplies. Then a watershed was utilized in the Catskill Mountains, 100 miles away. In this watershed, the runoff in streams is impounded by a dam with associated dikes and weirs to form a reservoir. Later, a second watershed was developed on the northern slope of the Catskills by constructing a dam to impound its water. From this reservoir, a tunnel 18 miles long passes under the dividing mountains and discharges its water into a creek, which flows into the reservoir on the south slope. From this Catskill system, water enters an aqueduct and continues on through this aqueduct for about 70 miles to an intermediate reservoir. Through the greater portion of this distance, the aqueduct is of cut and cover construction, about 17 feet in diameter. Grade tunnels carry the water through obstructing mountains. To underpass the majestic Hudson River, a pressure tunnel sinks 1,000 feet through the underlying rock. This enormous problem required extensive cooperative work by geologists, engineers, and other experts in tunnel construction. Cutting through solid rock hundreds of feet underground, as shown here, is only one of the many problems in constructing an aqueduct. Because of the difference in elevation, gravity provides sufficient pressure to transport the water from the Catskill reservoirs to the Kensico Intermediate Reservoir. The great bulk of this water remains in this reservoir for about 1 month. From here, it flows to a small equalizing reservoir, which takes care of hourly demand fluctuations. With increasing population and water consumption, New York City has been compelled to provide the Delaware system, consisting of 3 separate watersheds still farther away. This has necessitated the construction of a new aqueduct that finally connects with the original system. Represented here is the watershed system utilized by America's largest city. Just as important as an adequate water supply is a safe water supply. Municipal sewage treatment plants reduce pollution caused by sewage and industrial waste. Typhoid fever is one disease commonly carried by water. In one city, the installation of sand filters and the practice of chlorination was followed by a marked decrease in the number of typhoid fever cases. Until today, this disease is very rare where scientific controls are employed. The laboratory occupies a key position in safeguarding the city water supply. Water samples are collected daily. One test, known as a fermentation test, indicates the presence of contamination. Furthermore, the water is examined for microscopic organisms. Many of these organisms impart specific odors and tastes to the water. But certain bacteria cannot easily be detected under the microscope. Therefore, a measured amount of water is placed in a dish, and a sterilized culture medium is added and mixed. This is then placed in an incubator for 1 or 2 days. In this culture medium, each bacterium has now multiplied into a colony that is easily detected. These colonies can now be counted or examined under a microscope for identification. The water is also examined chemically for the presence of foreign substances that may affect its palatability or its use in industry and homes. The presence of ammonia nitrogen indicates organic decay and is determined by an elaborate test involving distillation. An indicator whose intensity of tint is revealed in a colorimeter gives a measure of the amount of nitrogen in the original water sample. Most surface waters pick up fine particles of clay or soil, causing turbidity. This is tested with a candle at the bottom of a cylinder. The water sample is poured in until the turbidity obscures the light of the candle. When water stands quiescent for some time, as in a lake or reservoir, however, much of this suspended matter settles out. To speed up this settling process, alum is often added to the water. This forms a flaky precipitate which settles out, carrying with it much of the suspended material and bacteria. Since alum makes water acid and corrosive, lime is added to render the water slightly alkaline. Many cities use filter beds of sand to remove this solid matter. This sight well, 8 feet deep, indicates the clearness of the water after treatment. Cities more and more mix activated carbon to the water to remove color, odor, and taste. Aeration is another common method of removing odors and increasing palatability of drinking water. The final step in water treatment involves adding chlorine. This completes the sterilization by destroying all harmful bacteria and other organisms. In New York City, water already made pure and safe enters the city through 2 huge tunnels drilled through solid rock about 200 feet underground. Risers bring the water up near to the surface. The water flows from the risers to connecting mains, then into lateral street mains, and finally through service connections into each building on the street. The higher elevation at the reservoir causes water to flow into the city by gravity. However, some consumption points are higher than the source, and pumps must be used. Many high buildings have their own pumps to maintain a sufficient water pressure to the top floors. The water thus provided has many uses. It flows through thousands of safe drinking fountains. It is used in the cooking of many of our foods, in laundering our clothing, and in other ways water contributes to cleanliness and health. Water is used in generating steam for heating buildings. Water aids in defending the city's health by flushing our streets and by carrying away sewage. Clean water plays an important role in healthful recreation. Water also is an essential part of the composition of beautiful fountains. The control of destructive fires requires water, sometimes in great amounts. Water, without which man cannot live, must be supplied in abundance and with safety to assure healthful living in a modern city.